Okay, this is the lecture for Chapter 3, Section 4, Newton's third law of motion. Newton's studies of motion and gravity led him to another critical law, which relates to the forces that bodies exert on each other. This additional relation, Newton's third law of motion, is sometimes called the law of action-reaction. The law states when two objects interact, they create equal and opposite forces on each other. You've been told before, for every action, there's an equal and opposite reaction. Actually, it's for every force, there is an equal and opposite force. And we can explain this through these skateboarders down here, okay? These two, we're going to say, have the same mass. They have equal mass. So when they apply a force to each other, they're both going to move away at the same acceleration. F equals mass times acceleration, all right? On the other hand, if I have this girl and this bigger person, this bigger man here, when she pushes, she's pushing and applying a force. The F is equal, okay? But since M is different, their accelerations are going to be different. This will make more sense when you look at the notes. I explain it more and I show how F equals ma works with this. For every force, there's an equal and opposite force. Okay, so the girl is going to push on the boy, but since the boy is larger, he has a smaller acceleration. She has a higher acceleration. F equals ma. All right. The same principle explains why a spacecraft accelerates in response to firing its rockets. It is often incorrectly believed that the propellant pushes against the ground or the air. But if that were true, a spacecraft would be unable to accelerate once it's in space. Why? Because in space there is no air, or the ground is not there. By Newton's third law, pushing propellant out of the rocket nozzle produces an equal push in the opposite direction. And that is how a rocket functions in space. All right, that's it for this lecture. Good luck.